go.
Now.
Hello, track people or whoever is gone. We are getting ready to take notes on, this is what, chapter 7? 7-1? 7-1, okay. And I'm going to do it a little bit different because I'm going to have you guys on the back side of your unit circle. I had them write this stuff down because you're going to make reference to this when you have, like, we won't test over this chapter, but it'll be on the semester final. So you'll want to make sure you have the graph of sine, cosine, and tangent on the back of your unit circle. So this, what we have written right here, is the back side of your unit circle. What? Not over this chapter, but it will be on the semester final. Yep. Okay, so sine, cosine, and tangent. We talked about sine and cosine on Friday, whatever day that was, okay? And I'm only going to graph the first period of sine, okay? What does a period mean?
From pi to, or 0 to 2 pi.
So, like, girls, you know, like, that's why they call it this. It's the time of period before it starts over again, right? That's what a period is, which is kind of like girls. That's the way that it goes, right? It's before it starts over again, okay? So it's one full cycle. I'm just putting it in terms that you can understand, okay? So it's one full cycle before it starts over again, okay? So 0 to 2 pi, that's one full cycle. That's then he starts over again, okay? So if we label our number line, we go 0 to 2 pi. What's exactly in between those two? Pi. Okay, what's in between the first quarter?
Hang on, flip it over.
Pi over 2, okay, is how we label it. A half a pi, right? And what's right here?
3 pi over 2.
3 pi over 2. That's how we label him, okay? So he has those labels. And then we start to draw the graph of sine, okay? So sine starts at 0, 0. He starts right here. And then how high does he go?
To 1.
To just to 1, and he goes down to -1, okay? So at pi over 2, he hits 1, right? And you can see that on your unit circle. You can look those numbers up. 0, at pi over 2, he's at 1, okay? At pi, he's back down at 0 again. Okay, what about 3 pi over 2?
Negative.
He goes down to -1. And at 2 pi, he is up to 0 again. And he goes like this, and he curves around. And he curves, and I'm trying real hard to curve it nicely, whatever. Okay, so that's what he looks like. Okay, that is just one full period, because what happens over here? Does he just like stop over here and like nothing's over there? He keeps going, but he cycles again, right? So like he would continue going up here and he would continue going down this way. So he does go left and right forever, but that's just one full chunk of it. Okay, everything after that is like a repeated like chunk of what this one is, right? Okay. All right, so let's fill in domain and range. Like domain is all the x's that he touches and the range is all the y's that he touches. So x's go left and right. What's the domain going to be? All reals, right? He'll be all reals because he'll go left and right forever, right? Because that wave just continues to go left and right forever, okay? The range are the y values. How high does he go? How low does he go?
-1 to 1.
-1 to 1. Okay, so do you remember how we write that? Y, which is less than or equal to 1. Yeah, because it's y in this case. Okay. Now, should he be equal to, or should we just put less than?
Equal.
Equal to, because he is touching physically -1 and touching physically +1, right? So those are my domain and range for sine. That is the sine curve. Okay. Are we ready for cosine?
Yes.
Yeah.
Cosine, we label exactly the same. We start at 0 and we go to 2 pi because that's one full cycle. And pi is in the middle. And pi over 2 is in the middle of that. And 3 pi over 2 is in the middle of that. So we still have the same units because cosine has the same period as what sine does. Okay, maybe let's label that. I'm gonna go up at the top here. I'm gonna go over here to the right side and let's say period is 2 pi. Okay, and this guy has a period of also 2 pi. Because it takes 2 pi before it starts to cycle a new one again, right? A new cycle again. Okay?
That's not how it is with tangent.
That's not how it is with tangent. It's a little bit different. Sine and cosine are very, very similar to each other. Tangent's a different beast altogether. Okay? All right, so ready for cosine?
Yeah.
What's the difference between cosine? Like, where does he start?
Up in the air.
He starts up in the air. So instead of him starting down here at 0 right there, okay, he starts up here, and then he goes down. Pi over 2 touches 0. At pi, he is at -1. Then he goes back up again, right? So he does kind of a little like cursive V thing. And that's what he looks like, okay? Which is kind of like what sine is, just shifted over, right? Okay, he's just he just looks like that. Well, that's what cosine looks like between 0 and 2 pi. Okay. I don't remember if it was Lily that said this the other day. If I continue this on down here, like touching there, and I just look at this chunk from here to here, don't write this down. If I just look at that chunk, that is exactly what sine is, right?
Oh,
Do you see
Ellie
that?
said that.
Yeah.
So Ellie said that? Okay. So touching back down to 0, if I continue him on back, he is exactly what sine looks like, right? So we've just moved him over, and that's what cosine is. Does that make sense?
Yes.
Okay. So I guess if you want to put that, you
So
can.
domain and range is the same?
So is the domain going to be all reals again?
Yeah.
Yes, because he's going to touch forever left and right. Okay. The range,
Same thing.
still same thing. -1, less than or equal to y, less than or equal to 1. Okay. Okay. So on Friday, we answered questions like, let's say for sine. Let me give you a question on here. From 0 to 2 pi.
You want us to write this down?
You can if you want. From 0 to 2 pi. Where is sine of x equal to, let's say, 1? I'll say, where is sine of x equal to 1?
0.
Where is sine x equal to 0? Where is sine x equal to -1? We'll just answer all those questions. How about that? Okay, not terribly hard. Just from 0 to 2 pi. Where is sine of x equal to 1? Where is sine of x equal to 0? Where is sine of x equal to -1? So where does he touch 1 at?
Pi over.
Two. Pi over 2.
Pi over 2. Where does he touch 0 at?
Pi.
0 and at pi and at
2 pi.
2 pi. All three places, right? Where does he touch -1 at?
3 pi.
At 3.
3 pi over 2. Does this make sense? Kind of?
Yes.
Yeah? Okay. All right. Should we do the same thing for cosine?
Yeah.
Sure. I'll write this out. From 0 to 2 pi. Where is cosine of x equal to 1? Cosine x equal to 0. Cosine x equal to -1. Question. Okay. Do you remember what we said on Friday? When do we use like sine and cosine functions like in the real world?
Waves.
Like waves, like sound waves, like vibration waves, those type of things. Those are all modeled by sinusoidal functions, which is sine, cosine, and tangent. Sinusoidal functions, that's what the names of these are, instead of like linear functions or quadratic functions or cubic functions or radical functions. These are sinusoidal functions. Those are sine, cosine, and tangent. Those are just like the category of each one of these. Okay? All right, should we answer the questions for cosine? Where is cosine 1? Where does cosine touch 1? At 0. He's up here, right? Okay, so he's touching there at 0. Where is he touching 0?
2 pi. I mean pi over 2 and 3 pi over 2.
Pi over 2 and 3 pi over 2. Okay, and where is he touching -1? Oh, wait a second.
No, because it wouldn't be 0 between
Wait,
pi
1
over
is 2 pi too.
1 is also 2 pi, so we need 0 and 2 pi where he's touching 1, because he's touching here and he's touching there. Okay, cosine's -1 at pi, right? Okay, there we go. That's good. All right, that's kind of stuff that we talked about on Friday, right? But now you have it at the back of your unit circle so you can make reference to it. Yeah, there you go.
Next.
Next,
No.
we're ready for tangent?
No.
Tangent. Tangent is gross. Tangent's really yucky.
That's good to know.
Okay? Tangent, here we go. This is what tangent looks like. Oh,
I got
Over?
everything but the math part done.
I'll just leave him there. How about that? Okay? All right, here's what I want you to put for tangent. Tangent is kind of a beast to graph, okay? Tangent has vertical asymptotes. Do you remember what those look like? Vertical asymptotes. Those are the dotted lines that never get touched, right?
Yeah.
Okay? Dotted lines going straight up and down. So I want you to put a vertical asymptote like here. And I want you to put a vertical asymptote at the same spot on the other side. Okay? Those are my vertical asymptotes. Vertical asymptotes are straight up and down. There and there. And those two places are located at pi over 2 and negative pi over 2. Okay, and here's what tangent looks like. It looks nothing like sine and cosine. Tangent reminds me of an x to the third power function, which does one of these. You know what I'm talking about? And he does one of those. That's what tangent looks like. That is one full period of tangent. Whoa, he's weird.
We write that?
Yep,
Wowzers.
yep. That's what tangent looks like, okay? Now, he does continue to cycle on forever, so he does one of these and does one of those again, like he does those all the way through, right? Okay? But this is one full period of tangent, okay? Given that, how big is tangent's period before he starts over again? Like, how wide is he?
He's a pi.
He's a pi wide, right? The other ones were 2 pi wide before it starts over again. Well, how does she know that he's a pi wide?
You add them together.
Right? Like the distance from here to here is pi, right? Pi over 2 on one side, pi over 2 on the other side. So he is a pi wide. That's how long. Why you did. No. I am kind of surprised that you knew that because you were gone on Friday, so you don't really. Yeah, you're still. She's just picking up. Awesome. Okay.
Common sense.
All right. So there is that. Period is pi. I want to label one other thing in here, and that is this. What is halfway between 0 and pi over 2 right there? What's halfway
Pi
between
over 4.
pi over 4? So label pi over 4 real quick, and label negative pi over 4 real quick, because do you know where they touch the graph?
No.
1 and negative 1.
Wow.
They're touching there at 1 and negative 1. So halfway between the center and the vertical asymptote, he's up there at 1, and he's down there at negative 1. That's where he's touching.
Oh my goodness.
Pi over 4 is at 1. Pi over 4 is at negative 1. Eventually, we'll get to a point where we make this taller. And so, like, let's say we say that he's 2 tall now instead, like 2 units tall instead. What he would look like is he would be up here at 2. So it's going to make him, like, a lot straighter up and down, right? Okay? At pi over 4, he would be up at 2 instead of at pi over 4 being up at 1. Okay? So don't draw that. But anyway, that's eventually what we're going to get to is making him taller by doing that to him. Okay? That's what tangent is. Let's talk about domain and range. Let's talk about range first. Range is the y's. The y coordinates, like going up and down.
Oh, wait. All real.
Going up and down, he is all reals, right? Okay? Now the domain is a lot tougher because does he touch everything left and right?
Negative pi over 2
No.
to pi over 2.
That's exactly right. Yeah. So where he doesn't touch is wherever these vertical asymptotes are located, right? Okay? So the first vertical asymptote is at negative pi over 2, right? The next one is at positive pi over 2. How far apart are those? Pi. Okay, there we're going to have another vertical asymptote over here. Again, how far later? Another pi later, and another pi later, and another pi later. We're going to have another vertical asymptote. So he is touching like all of the x's except those places. Okay, so the domain is that x is not going to be equal to. First of all, he's not equal to negative pi over 2 plus every unit of pi after that. So how do we note every unit of pi after that?
Etc.
What?
Etc.
Plus and minus pi k. So every pi k just means every interval of pi after negative pi over 2. So we add pi to negative pi over 2, add another pi to negative pi over 2, add another pi, or subtract pi. All of those places are going to have vertical asymptotes where the domain just like poops out, right? Okay, because that's where the period is located. Does that make sense? Yes. Okay, so that's what the graph of tangent looks like, all right? And you've got that on the back of your unit circle. That's what he looks like, all right? Good? Okay, let's go back to the notes real quick and we'll answer some questions and see how they break this down, okay? Because there's a couple other things that they're going to do to it. So go back to the notes. Let's see where we're at here. let's see what we got. Let's see what we got. Vectors. I'm not in the right spot. I'm not in the right spot. I want to be here. I want to be here. Right here. All right. So we just got done graphing the tangent function. That is on the second page. Second page. Okay. State all values of t for which tangent of x is equal to -1. All right, let me graph what you have right quick. Use your unit circle, the one that we just drew right next to what you have now. And this is what the graph looks like. And we have -pi/2, we have +pi/2. This is what we've basically just gotten in graphing, pi/4 and -pi/4. Okay, where does tangent equal -1 at?
pi/4.
Oh, this is a 4 right there.
pi/4.
-1, he's down there, -1 at -pi/4, right?
Yep.
Okay, so he is, the first time, for the first period, he's at -pi/4, or excuse me, he's at -1 when he is at -pi/4. Do you see how that works? But I want all values, not just the ones in the first period. Where is the next time that he's going to be at -1? Like right here, right? And the next time he's going to be like right here.
Plus pi k.
How often or how far is it in between those?
Pi.
Pi, so plus and minus pi k. So every interval of pi before -pi/4 and every interval of pi after -pi/4, he will be touching -1. Does that make sense? Yeah? Yeah?
What did you say?
So at pi/4, he's touching -1 on the graph. But he's going to do it again over here, and again over here, and again over there. And in between those two is a distance of pi. That's why we put pi k on the end. So if I want to know where he's touching -1, he's going to touch -1 a bunch of times for each cycle that he goes on.
Like every pi he touches.
Every pi, he's going to touch -1. Because that's how far apart the tangents are, right? Tangents period is pi. Does this make sense, kind of? Yeah? A little bit?
Wait. So every pi -pi/4 touches -1.
So he touches the first time at -pi/4 right here. This dot, whoop, this place right here is -1 at -pi/4. Right? That's where he's touching -1 the first time. But then he's going to do it again pi units later, again pi units later, etc. Does that make sense? All right, let's go ahead and answer this question. Okay, the next thing that they're going to throw at you is stretching things out. And a vertical stretch is very easy. Okay, we just got done graphing cosine of t or cosine of x. It doesn't matter what variable you use. But now they're throwing in this 4. Okay, what's the 4 going to do?
Move it.
Move it how?
Isn't it all bigger? Fatter.
Nope, not fatter.
Upper.
Taller.
And
Upper.
skinnier.
Taller and not really skinnier. Okay, the original cosine looked like this. He starts here, and let's go 2 pi. Let's make our markings. Pi is here. Pi/2 is here. 3 pi/2 is here. Okay, and normal cosine, I'm just going to say 1 is here and -1 is here, and he starts here. Oh, no, cosine. Cosine. Where does cosine start?
1.
Up. He starts at 1. So we're going to start here. And he's going to go down and down and up and up. Okay, that was graphed really fast. He looks like that. Okay, that's what normal cosine looks like. That's what just cosine of t looks like, or cosine of x. It doesn't matter what variable you use. That's what just cosine of x looks like. Okay, now it's not going to make him wider and skinnier. It's just going to make him taller. The 4 out in front just makes him go 4 units tall and 4 units short. Okay, so instead of starting at 1, he's going to start up here at 4, right? That's what the 4 out in front does. That's the only thing the 4 does. Okay, and then at pi/2, where will he be? At pi/2, where is he going to touch at pi/2? He's going to still touch at the same spot at 0. Okay, at pi, he will be down at -4. At 3 pi/2, he still touches at 0, and then he goes back up to 4. So this is what he looks like. By putting that 4 out in front, the only thing it does is just makes him like the waves taller.
So
You see that?
touch on everyone.
At +4 and at -4, if you want to label those. That's what he looks like. Oh, I don't know why I did that. +4, -4. Okay, it just makes him taller. He's still gonna cross the x-axis at the same spot, but it's just gonna make him taller than what he was before. Okay, that's what that 4 does, and that is called an amplitude change. Okay, so the amplitude now is 4, and what was it before? 1. Okay, now the people think all the time that the amplitude of the original cosine is 2 because he goes up to 1 and down to -1, right? But the amplitude is not 2. It's from the center point up to how tall he goes, or the center point to down below. So the amplitude of the original cosine is just 1. The amplitude of the cosine that we just graphed was 4, right? Because he goes up to 4 and down to -4. Does that make sense? Okay, so that's called a change in amplitude, and an amplitude change is just a vertical stretch. You're just making him taller or shorter. And all that does is that number out in front just changes it. Okay, makes him taller or shorter. Good? All right, let's go down to the next one. Okay, they want us to graph 1/2 sine of x on the interval from -2 pi to +2 pi. Okay, normally.
-1/2. You said 1/2.
Oh, -1/2, I'm sorry. Normally we just go 0 to 2 pi. So I'm just going to go 0 to 2 pi, and then we'll add in the other ones here in a second. Okay, pi over 2, 3 pi over 2, and let's just do that. Okay, and I'll go there also, those 4. -pi over 2, pi, -3 pi over 2, -pi, and -2 pi. Okay, there's the stuff that we want to graph. We want to graph from -2 pi to +2 pi. That's the interval that we're graphing on. Okay, and it says use a calculator, but we're not going to use a calculator because that's almost harder than actually just graphing it yourself. Okay.
Yep.
All right. So what does the 1/2 in front do?
Well, it makes it longer.
It makes
Well, shorter.
it makes it shorter. So the amplitude is now what?
1/2.
Is it -1/2 or +1/2?
Doesn't really
Doesn't matter.
matter.
It does matter.
Well, because the negative flips it. It's just half. But
So the amplitude is 1/2. Okay? Amplitude is never negative because amplitude is asking for the height of it. Well, you can't have a negative height, right? So amplitude is always positive. Always positive. But what does the negative do?
flip.
How does it flip it?
Like for, no, X and Y.
I mean, it flips it. It flips it over the x-axis. So normally, here would be 1, and here would be -1. So we're only going to a half, right? And down to -half, right? Up to 1/2, down to -half, okay? But normally, this is what sine would do. Don't graph this. This is what sine would normally do. That's what he would look like, right? So what's he look like now? Now that he's negative. Now he
Goes down first.
Now he goes down first, right? So he starts here and he goes down and up and this way. So he does that. That's what a negative does. A negative flips him over the x-axis. Negative equals x-axis reflection. Okay? All right, and then on the opposite side, he does the same thing. So I'm going to start at -2 pi, go down, up, put those 5 dots in there, and that really helps it so that you can graph, right? That's what he looks like. Anyway, so -2 pi to +2 pi is actually how many periods? Equals 2 periods, right? Okay.
Can you do the original? This one, like in a different color?
The original sine?
Yeah.
Okay, so the original sine looks like starting here, and he would go up to 1, and he would do this. This is what the original sine looks like. Okay, so we have made him shorter, because he's only 1/2 now, and we flipped him. So that's what that -1/2 does. And that's just one period. The other period would be the same thing, but on the other side. That's what he would look like. Is this making sense? It's a lot to label, right? Are we doing okay there?
Yeah, just wait.
Yeah. Yep. Yep. Are we doing tangent? Oh man. Tangent here.
Can you zoom out just a tiny?
I can, sure. Like that? Okay. 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 All right, the other thing that they will do to you is instead of this number being out in front, like we just did, the -1/2 like that guy, or the 4 like that guy,
They'll hide it.
what's the +5 doing on the end of here? What's a +5 normally do?
It shifts it over
Adds
5.
it.
Not over 5,
Adds it.
Up 5.
up 5. The +5 on the end, this is just shifting him up 5. Okay? All right, so we're graphing tangent, so get that in your brain, tangent. Where are the vertical asymptotes on tangent?
Negative pi over 4 and pi over 2.
Negative pi over 2 to positive pi over 2. Boop, boop, boop. Negative pi over 2 to positive pi over 2. Okay? All right, if I do that, where is the next vertical asymptote going to be located? Pi units later, but that would be at 3 pi over 2. Right? Where will the next one be? 5 pi over 2, right? If I'm adding pi each time. Okay? They want us to go to 3 pi. Where's 3 pi at? 6 pi over 2, which would be just like right here. Right there. That's 3 pi. 3 pi. Okay, same on the other side. This is -3 pi over 2. This is 5 pi over 2. -5 pi over 2. And then 3 pi, -3 pi will be over here. So it's like halfway in between the vertical asymptote. -3 pi. Okay? Do you see why we're going from -3 pi to positive 3 pi? Do you see why we're going from -3 pi to positive 3 pi? Because of this guy right here. That's what tells us. Okay? You really, when you're graphing, you really have to think about it. Okay? So we're graphing them kind of fast up here. Just because, like, this is all I do all day long, and I graph them, and I can graph them fast. But when you graph them on your homework assignment, it might be a little bit tougher to do and take you a little bit more time, and that's okay. Okay, the first graph of tangent looks like this. And then he does, oh man, let's try that again. There we go. There we go. Okay, I'm going to put a dot in the center there. Graph him. Put a dot in the center again. Graph him. Okay, I'm going to do that over here too. Put a dot in the center. Graph him. Put a dot in the center. Graph him.
Wait, why is
And on the ends, what does that look like? Only a half of a 1, right? It's only going to get to here. And it's the other half. It's the tall half on this side, which looks kind of weird, right? That's from -3 pi to positive 3 pi. Okay, so we got 2 halves and 5 holes, which is 6. 6 periods, right? 6 periods of tangent. Does that make sense? It's 5 periods in the middle and a half a period and a half a period, which is 6 periods. Now, should it be 6 periods? If it's going from -3 pi to positive 3 pi,
Yes.
that is 6 pi's, and 1 tangent is just pi, right? So that would be 6 periods from -3 pi to positive 3 pi. Make sense?
So what do we,
Oh, poop. Except, you know what?
We forgot to add 5.
We forgot to go up 5. So you know what we do?
Move it up 5.
We take this and we go like this, and we say that this guy's not here, right? Get rid of that line, and where do we put him?
5 up.
down.
Down.
Move him down 5, right? Like 1, 2, 3, 4, 5, and now our x-axis is now right here, down at -5. Does that make sense? So he's way up in the air, right?
Actually, he's way down in the air.
No, he's way up in the air.
That's negative, that's down.
No, but the graphs are way up in the air.
Oh, yeah.
Like the graphs are way up in the air, like that.
Or you can move them, tap them with your finger and
What?
drag them down.
You can. Can you drag all of them down at the same time? No, you would put all of them up at the same time.
Yeah.
Can I tap them all and move them all up?
No, but you can tap this little thingy thing.
The little lasso-y thing?
Yeah, and circle it all and move it down.
Okay. I'm just gonna leave it the way it is.
The more you know.
I'll practice that later. Okay. So there you go. We just cheated, but that's okay. Instead of rewriting it all. So that x-axis is not there. The x-axis is actually down 5. No.
it was supposed to be up?
Come on, Trig.
It was supposed to be.
Okay. No. I just labeled it wrong. So the -5, that's not actually -5.
It's 0.
This is at 0, right? We've just moved 0 down. So this is the x and y axis. So this mark right here, that's an imaginary line. This is up at 5 right there. Does that make sense?
Yes.
Yeah, now it makes sense. Okay, so that's actually the x-axis, which should be 0, right? So we have moved everything up 5, right?
Are we skipping
These
the
are
other
the
two
x-axis.
things?
What?
Can we skip the other two things?
What do you mean? Even, odd?
Yeah.
Sure, yes. We will skip even, odd. Okay?
Can you review?
Yes, yes. Okay, so do you guys have your homework assignment?
Yeah.
Yes? Do you know what you're doing?
Yeah.
Yep, yep. All right. I think the only ones that you really have to graph are 14, 15, 16, and the first 3, which is just sine, cosine, and tangent. Okay? Those are the only graphing ones. And it is hard to graph. Okay? But do your best. All right? The rest of it's just answering questions. Okay? Do the best you can. 17 to 22 is just matching, and you should use one for each one. Okay? Good?